So in this lecture, we are going to look in detail about critical path method. We will also study what is float and how can we calculate the critical path method and float so that we can make important decisions about scheduling in the project. So what is critical path and critical path method? The critical path is the longest sequence of activities in a project plan which must be completed on time for the project to complete on due time. It indicates the minimum time necessary to complete the entire project. So basically when you are making a Gantt chart or when we are scheduling the project, when we are planning that the duration between the start and the finish time of a project should be a particular number, we should know what should be the minimum time necessary to complete the entire project. And if we know the minimum time necessary, then we can plan about the other important resources such as cost or finances, human resources, and many other resources which will be required in the project. But before that, let us understand float. Often, if you are a project management professional or if you are going to participate in the PMP examination, you will encounter this term quite often. There are three kinds of float. Float is just the delay of activity. And float provides you the option to delay activity for certain time without affecting the project. As I already told you, there are three kinds of floats. The first one is free float, on which the activity can be delayed without delaying an early start of any successor activity. Then there is a total float, in which activity can be delayed without delaying the project completion. And there is a project float, in which projects can be delayed without the planned customer's expected completion date. In the PMP examination, chances are that you can get the questions to calculate the total float. And in this lecture too, I will show you how to calculate the float so that you can delay any activity. Now this is an example of the critical path method. I am going to show you the critical path method with different calculations. But before that, you have to understand certain things. First of all, these squares that I have shown you here represents the different project activities. A is the start of project activity and K at the end is the finish point of the project activity. Other different points B, C, D, E, F, G, H, I and J are the individual project activities of the project. Now project could go in a different pathway according to the objective. Suppose some activities of the project can go a pathway of A, B, E, H and K for meeting particular objective, and other pathway can go from a different pathway. For example, the other pathway are A, C, F, I, J, K and A, D, Z, I, J, K. Our job with the critical pathway method is to find the critical path, that is the longest sequence activity pathway. The first space on the square, which represents any single process in the project, stands for early start. The upper right space indicates early finish. And the middle stands for duration. Early start stands for how early can we start the project, and early finish stands how early can the project be finished. In the forward pass method, we can calculate early finish and the early start. I will also show you how to calculate late finish and late start later. But for now, let us calculate early finish and early start. There are distinct three paths to complete the project. The arrow shows the flow of the work in the project. For example, if we talk about the flow of work between the process A and B, the tip of the arrow points to B and the tail of the arrow touches the A. That means the work is flowing from A to B. Similarly, the work is flowing from B to E, E to H, and S to K. Now let us start the early start and early finish with a formula. I have given the formula on the top right corner. In the forward pass process, the early finish is sum of early start and duration minus 1. We already have the set duration or the planned duration for each of these processes A, B, E, S, K, And similarly for the other process C, F, I, J and D and Z. So for the process step A, the duration is 3. We are trying to find the float here. Float is also called the slack, and it represents how much the project can be delayed from the early start without changing the completion date of the project. So here, suppose we want to know how many days can we delay inside these project activities so that we can complete the project in the final completion date. Now using the formula above for the forward pass method, early finish is the sum of early start and duration minus 1. We always put the early start day as 1 because we start the project from D1, and early finish is 1 or the early start plus duration 3 minus 1, which gives us 3 days. So if we complete the project at earliest for the path A in 3 days, the early start for the process B could be 4 days. And similarly, the early start for C and D will also be 4 days because the early finish of the prior step or the step A is 3 days. So we put the early start of C and D as 4 days. Similarly, the early finish of B is 4 plus 7 minus 1, that gives us 10. For C, 4 plus 6 minus 1 gives us 9. And for D, 4 plus 8 minus 1 gives us 11. Similarly, we completed the B at the 10th day. So the early start of the E will be 11 day. Similarly, for F it's 10 days and for G it's 12 days. By using the forward pass method, we can know the early finish of the E, F and Z. 11 plus 4 minus 1 gives us 14, 10 plus 2 minus 1 gives us 11, 12 plus 3 minus 1 gives us 14. Similarly, for H, the early start is 15 days, and here is one tricky thing. For I, it's not 12 days, it's the 15 days, because I is the step which we can start after both F and G are completed. So we can start the I only after both of these process steps are completed. We already completed the process step F in 11 days, but G took 14 days. So we can start the I only after we have found the early finish of the process G. So the early start for the process I is 15. And using the formula for the forward pass, 15 plus 7 minus 1 gives us 21, and 15 plus 2 minus 1 gives us 16, which are the early finish of H and I. Now, as we go from I to J, the early start is 17, and early finish is 18, and as we go from S to K, the early start is not 19 here. So this is also quite tricky one, because both process steps H and J leads to the process K, and we can start the process K only after both the process H and J are completed. Process J, the early finish is 18 days, but we can start the process K only after process H is completed, which takes a longer time. The early finish of process H being 21 days, we can start the process K only after process H is completed, and so the early start of the process step K is 22, and the early finish of process K is 22 plus 3 minus 1 gives us the 24. So by this way, and by using forward pass method, you could clearly see what should be the early start and early finish of each of the steps inside the project. Now I'll teach you how to calculate the critical path. For calculating the critical path, you just have to sum up the duration of each process steps. For A, B, E, S, K, it's 24 days. The duration of A was 3, B was 7, E was 4, S was 7, J was 2, and K was 3. The duration number is the number in the middle of the early start and early finish. So 3 plus 7 plus 4 plus 7 plus 3 is 24. Similarly, for pathway A, C, F, I, J, K, it takes 18 days. 3 plus 6, 9, 9 plus 2, 11, 11 plus 2, 13, 13 plus 2, 15, 15 plus 3 gives us 18. For process pathway ADZIJK, it takes us 21 days. So we can clearly see from here that the longest path is the path A, B, E, S and K, which takes us the 24 days. So this is the critical path. But here, critical path is the minimum time it takes to complete the project. We know that there are other paths for the completion of the project as well. There are the other steps. We can follow the ACF IJK and ADG IJK. So as one of the project path takes 24 days, we can delay some days while we go from the path ACF IJK or ADG IJK, as they take lesser time than 24 days. So we can delay the path ACF IJK by 24 minus 18, that is 6 days. And we can delay the project ADGIJK without affecting the final completion of the project by 3 days, that is 24 minus 21. So this is called float. If you are asked in any project management related examination to calculate the float of any pathway, you have to first calculate the path length of each path, and you have to subtract duration from the critical path, or that path which is taking the longest number of time. So for your revision again, the critical path is the sequence of project network activities which adds up to the longest overall duration, regardless if that longest duration has float or not. It is the longest overall duration. Now as we know that the project takes 24 time, the late finish of the project is also 24. There is a formula for the backward pass which helps us to calculate the late start time. Late start is late finish minus duration plus 1. Now coming to this point, we know that the critical path is A, B, E, S, K, as it takes the longest number of time and it is completed in 24 days, which is the early finish. For the critical path method, the late finish is also the early finish. So our early finish is 24. Our late finish will also be 24. And using the formula for the backward pass, late start is late finish, that is 24. The space for the lower rightmost side of the square is for the late finish. 24 minus 3, which is the duration, gives us 21, plus 1 gives us the 22. So our late start is 22 and our late finish is 24. Float is the difference between early start and late start, or early finish or late finish. 22 minus 22 gives us 0, or 24 minus 24 gives us 0. In most of the cases of the critical path, the float is always 0. So here too, as our A, B, E, S, K is a critical path, we got a float as 0 here. For the process H, as our late start for the process K was 22, our late finish for the process H will be 21 days. The duration being 7, 21 minus 7 plus 1 gives us the late start of process step H as 15 days. So the float here too is 0. Similarly for E, as the process H, the late start was 15, the late finish of the process E will be also 14. Late start is 14 minus 4 plus 1 gives us 11, and the float is 0. And similarly, we can find out the late start and late finish for B and A also. So what do we see here? We see a unique information. That is, for the critical path, the earlier start and late start and the earlier finish and the late finish is the same, and we are getting the float as 0. Now it's not necessary that for the critical path the float should be 0, but while calculating the backward pass or forward pass, we should understand for critical path the earlier start should be equal to earlier finish and late start should be equal to late finish. So coming to this point, we knew that the critical path was A, B, E, S and K, and We also calculated the earlier start and late start and early finish and late finish for the pathway A, B, E, H and K. We also learned that the information on the lower side of the box stands for the late start, float and the late finish. By adopting the same method, if the late start of process step K is 22, then the late finish of the process step J will be 21 days. So by adopting the same method, we can calculate the early finish and late finish. There may be one confusion while we backward pass from the process step B, C, D to process step A. We see here that the late start of B is 4, late start of C is 10, and late start of D is 7. But the late finish of A is 3, because we should select that pathway which has the minimum time when we are doing the backward pass. The minimum time between B, C and D is 4. So our late finish for A will be 3. And similarly, by using the backward pass method, 3 minus duration 3 gives us 0 plus 1 gives us the late start, which is 1. Now float for process step A, C, F, I, J, K is the 6 days. Similarly, for A, D, Z, I, J, K, it's 3 days. We can calculate the float by directly subtracting the process duration from the critical path, or by subtracting the early start from the late start, or by subtracting the early finish from the late finish. So if we are going through a pathway A, C, F, I, J, K, we have a 6 days flow. In the PMP examination or in any project management examination, or also in your professional journey in the project management, suppose it happened that you had to delay process step C for 3 days. So what is the maximum amount of time you can delay for the next subsequent activity? That is process F. If I ask you that, it will be 3 days, because you could delay the whole pathway A, C, F, I, J, K by 6 days. If you use already 3 days of that 6 days for the process step C, only 3 days will be remain to be delayed for the process F. So with the help of calculation of the float, we can determine how much we can delay in each of the process steps. So this is one of the application of the critical path method or the calculation of the float. The critical path method can be a little difficult to understand or grasp when you are first learning. That's quite logical and it's completely normal. I've taken many technical terms like early start, early finish, late finish, float, critical path, forward pass, backward pass, etc. in this lecture. So if there is any confusion in the new terms that you learned just now, you can revisit the lecture again. So thank you so much.